Okay, so in this lesson, we're going to look at how to rewrite a quadratic function that is written in general form to standard form. And we're going to do this using completing the square. Now remember, general form, a quadratic function in general form looks like this. It's f of x equal ax squared plus bx plus c. So that is, this right here is general form. And what you want to do is write it in standard form, and this is sometimes called vertex form. So sometimes called vertex form. So remember, if you see the word standard form or vertex form, they mean the same thing. Now remember, vertex form looks like this: f of x equal a times x minus h squared plus k. So remember, that's vertex form. It's vertex form because the vertex is hk. And we're going to do this by completing the square. All right, now remember you used the idea of completing the square once before, and you did that with circles. So let's review an example. So remember the general form for the equation of a circle looks something like this, and here's an example of a circle that's written in general form. So let's suppose we had x squared plus 4x plus y squared minus 8y plus 5 equals 0. All right, and so remember this is the equation of a circle in um, general form. Okay, and what we want to do is write this equation of a circle in standard form. Okay, so what you did first was remember when completing the square, you completed the square on the x terms, and you completed the square on the y terms. All right, so you group the x terms together, and you group the y terms together, and then you brought the constant to the other side. So this is what you did. You said, well, I'm going to rewrite this as x squared plus 4x, and then I'm going to leave a space here because I know I'm going to be adding something to these two terms to make this a binomial squared. So hence the idea of completing the square. So you wrote this as a binomial squared. Then you do the same thing with the y terms. So you said I'm going to rewrite this as y squared minus 8y plus some number. So when I complete the square on the y's, I'm going to be adding a number here, so that way whatever I add here, this is going to be a binomial squared. That trinomial will now be a binomial squared. And then equal, and you brought this 5 to the other side, so it became negative 5. But remember, when you add something to one side of an equation, you have to add it to the other side. So whatever you put here, and whatever you put here as well. Okay? All right, so here's how you complete the square on the x's. So you took well, first of all, make sure that the coefficient of x squared is 1 and the coefficient of y squared is 1, and it is. And the examples we did, they were all 1s. Then the next thing you're going to do is take the coefficient of x, which in this case is 4, and you divide by 2. Always divide by 2. And you're going to get the number 2. And then you take that number you just got from this division by 2, and you square it. And when I square it, I get 4. And that is what you add here, and that is what you add here. What you do to one side, you do to the other. And now when you factor this, this is now a perfect square trinomial. So this became, x plus 2 squared, because x plus 2 times itself is this trinomial. Then you did the same thing with the y. So you took half the coefficient of negative 8. So you took half the coefficient of negative 8. So negative 8 divided by 2 is negative 4. You take negative 4 and you square it. And when I square negative 4, I get a positive 16. Negative 4 times itself is a positive 16. And then you add it to both sides. Now, if you're doing this correctly, this should now be a perfect square trinomial. So when you factor it, you should get y minus 4 squared. And then equal, and then this would be negative 5 plus 4 is a negative 1. Negative 1 plus 16 is 15. And that was the equation of a circle in standard form, right here. And so from here, you could determine the center of the circle. So remember, the center here was now going to be negative 2, positive 4, and the radius is equal to the square root of 15. All right, so that's a review of completing the square. And that's what you're going to use here. So you're going to rewrite a quadratic function that's in general form, this form here, into vertex form or standard form, which is this form here. Because you remember, you're trying to get a binomial squared, and so you see that's a binomial squared here, a binomial squared. So you're trying to complete the square in this, so it looks like this, a binomial squared. All right, so let's look at some examples. So let's look at number 1, and listen carefully to how you're going to do this. Is very important, because notice that when you wrote the equation of a circle, first of all, a circle, this relation is not a function. See, this is written in function notation, so it's a little different. The idea of completing the square, though, is almost the same, but and when I say almost, it's the process you go through when moving things around. All right, so let's look at number 1. So number 1, let's suppose we're going to start out with a simple example. F of x equal x squared plus 8x plus 12. All right, and so you want to rewrite this in vertex form. All right, now what I would do first, and again it's up to you, but it is okay if you rewrite f of x as y, so that way you don't have these little parentheses floating around. All right, so if you want to rewrite f of x as y, you can. It's up to you. But I'm just going to go ahead and leave it as f of x for right now, and then maybe in one of the examples I may change it to y, but it doesn't matter. All right, but here's the idea. So remember when, and this is the approach we're going to take here. So remember when we did the equation of a circle, we brought the constant to the other side. So let's do the same thing here. Let's bring this constant to this side here. So I'm going to subtract 12 from both sides. So I get f of x minus 12 equal x squared plus 8x. All right, now I want you to notice something. So now you remember what we did here. So we took the x terms, we took the coefficient of x, and we divided by 2, and then we squared that number. Okay, and then we added to both sides. You can do the same thing here. So watch. You're going to take, now again, make sure this is a 1 right here, and it is. So we're going to take the coefficient of x, which is 8. I'm going to divide it by 2, and I get 4. When I square 4, I get 16. And so I added here, what you do to one side, you do to the other. Okay? All right, just like you did with the circle. What you do to one side, you do to the other. Now let's combine like terms on this side. A negative 12 and a positive 16 is a positive 4. So you get f of x plus 4 equal, and then now this should now be a perfect square trinomial. So remember when we went back to the circle, once you put that number here, we then factored as a binomial squared. So this is a perfect square trinomial. So we can do the same thing here. So when I factor this, this is now going to be x plus 4 squared. And then all you do is get f of x by itself. So now you're going to subtract 4 from both sides. And so you get f of x equal x plus 4 squared minus 4. And so that is this right here. Once you get, remember, vertex form is this, a times x minus 8 squared plus k. All right, so we have it now in this form. So from here, now you can determine the vertex. So the vertex is negative 4. Remember, take the opposite of this. And then your k is negative 4. So negative 4, negative 4. All right, now you see it's a lot easier. Some students so if you ask to graph this function, some students prefer to write this in vertex form to graph it, because you can use transformations to help you. See how in a previous lesson you talked about transformations. So in terms of transformations, you would take the parent function, which is x squared. Then you would move it to you have a horizontal shift here, so you move it to the left 4 units and then down 4. And then you go from there. In the next lesson, you're going to see how to use this to graph a better quadratic function. All right, so that's how you do that. So it's not that difficult. It's just using ideas you've learned in the past. So let's look at another simple example, and then we're going to look at a couple of harder ones. All right, so let's look at this one now. So let's say g of x is equal to x squared plus 4x minus 16. All right. Now, Just keep in mind that when for the coefficient of x in each case, I'm making that a number that's divisible by 2. So for our examples, they're both even. All right, just keep that in mind. That's for right now. That's what I'm using. We're going to do one where it's not an even number, just to show you what to do. But they're going to be even for right now. Okay, so remember, you want to complete the square. You want to change this to vertex form. So you want to write as g of x equal a times x minus h squared plus k. So we write in vertex or standard form. All right, so then we're going to add 16 to both sides just to get the variables by itself. So I'm going to do is add 16 to both sides just like this. So on this side, I get g of x plus 16 equal, and then this is 0 right here, so all I'm left with is x squared plus 4x. All right. Now I'm going to complete the square on the x terms now. So this has a coefficient of 1. We're going to keep talking about that. Make sure that's a coefficient of 1, and it is. So once it's a coefficient of 1, you take half of x, the coefficient of x. So 4 divided by 2, is 2. Then I take 2 and I square it, and I get 4. So now that's what I'm going to add to both sides. What you do to one side, you do to the other. Now let's combine like terms on this side. So 16 plus 4 is 20. So I get g of x plus 20 equal, this should now be a perfect square trinomial. And so when I factor this, I'm going to get x plus 2 squared. Now, all you got to do is just get g of x by itself now. So subtract 20 from both sides and you're done. So g of x is equal to x plus 2 squared minus 20. So there's your vertex form or your standard form. So remember that's standard or vertex form. Okay, and once it's in vertex form, you can easily determine the vertex, and you can also use this to help you graph this quadratic function, which is going to be in the next section. All right, so then the vertex. Now remember, all they want is the vertex form, so that's your answer right here. But just remember that the vertex here is -2, -20. All right, so that's your vertex standard form. All right, let's do number 3. Number 3, let's suppose we had this for number 3. All right, so let's suppose we had h of x. All right, so number 3, we have h of x equal x squared minus 10x minus 3. All right, so again, let's go ahead and add 3 to both sides. And so when I add 3 to both sides, I get x squared minus, I get h of x plus 3 equal x squared minus 10x. Okay, now we're going to, this has a coefficient of x, x squared has a coefficient of 1 now, so I'm going to take the coefficient of x, which is -10, not 10, -10, divided by 2, I get -5. Then you have to square -5, and you get 25, and that's what you add to both sides. So plus 25, plus 25. And so now we get, when you combine like terms, we get h of x plus 28 equal, and this should now be a perfect square trinomial. So we get x minus 5 squared. And then all you do now is once you get this into a perfect, once you factor this, you get into a binomial squared, then you just solve for h of x. So subtract 28 from both sides. And so you get h of x is equal to x minus 5 squared minus 28. So there's your vertex form, standard form. So that's your standard form. Okay, so that was number 3. Let's look at number 4. In number 4, let's go ahead and do one where the coefficient of x is not an even number, just to show you what to do. Okay, so number 4, we have, let's say f of x equal, and then x squared plus 9x minus 2. So let's say we had that. Okay, all right, so again, the coefficient of x squared is 1, so that's a good thing. Then let's go ahead and add 2 to both sides. And so when I do that, I get f of x plus 2 equal x squared plus 9x. Okay, now I'm going to complete the square on the x terms. So the coefficient of x squared is 1, so this is where I take 9 divided by 2. Now remember, 9 is not divisible by 2, so leave it as a fraction. Don't put it as a decimal. You're gonna have some issues here. So the only difference between this one and the others is that when I divide it, the coefficient of x were even numbers. So when divided by 2, you got a nice integer uh, as as your um, as your result when you divide it by 2. Here, that's not a nice integer. In fact, that's not even an integer. It's just a rational number. But so there's nothing else you can do to this. And then now what you're going to do is you're going to square this. So you're going to square it. And when I square it, because remember, you're going to square, right? Once you divide by 2, you simplify, then you square whatever that number you get when you simplify. And you do the same thing here. You just can't simplify that any further. So 9 times 9 is 81, and then 2 times 2 is 4. And that's what you add to both sides. You can say plus 81 divided by 4, plus 81 divided by 4. Okay? Now, when we combine like terms, those were easy because those were all integers when we did that, right? Okay, those are all integers. Here we have an integer and a rational number. So if you need to use your calculator, use your calculator. So just remind ourselves how to deal with this. Now, if you don't have access to a calculator, let's do the part where, let's say you don't have access to a calculator. So you want to add 2 and 81/4 together. Let's remind ourselves how to do that. Okay, so remember when you add two fractions together or two numbers together, one's a fraction or both a fraction, you have to have the same denominator. So remember that's 1 here. So the LCD is 4. So the LCD is 4. So you're going to write two fractions with a denominator of 4. So 2 divided by 1 is equivalent to what fraction with a denominator of 4? So remember what you did was you said, well, if that's a 1 and I want it to become a 4, then I'm going to have to multiply this by 4. What you do to the denominator, you do to the numerator. So 4 times 2 is 8. This is already a 4, so 81/4 is equivalent to itself. Times 1 times 1. So 81 times 1 is 81. So then 81 plus 8 is 89, so you get 89/4. Okay? So that's what this would be. So you'd say f of x plus 89/4. Now, if you have access to a calculator, let's remind ourselves how to do this. Now, remember, you need to know how to use your calculator. So this is the one I'm using. That's the one that was on the syllabus. So you're going to say 2 plus 81/4. So just say this. For right now, you're going to say 2 plus 81 divided by 4. It writes as a decimal, but you want to rewrite this back as an improper fraction. So then to do that, you're going to press second and then P or B right here. So it says fraction to decimal, decimal to fraction, press equal, and it puts it as a mixed number. So I want you to remember though, 22 and 1/4, you got to change that back to an improper fraction. So 4 times 22 is 88. 88 plus 1 is 89. Okay? So that's how you can use your calculator with this. And now over here, this should now be a perfect square trinomial. So you just got to factor this. So when you factor this, you're going to get x plus 9/2 squared. And it kind of makes sense because 9/2 times itself is 81/4. Okay, and when you remember it's a binomial, so binomial squared. So this is when you FOIL it out, you're taking 9/2, multiplying it by 2, and that's going to give you 9. All right, and then all you do now is just subtract 89/4 from both sides. And so you have your answer. So f of x is going to equal x plus 9/2 squared minus 89/4. Okay? All right, so that's your vertex form. That's a vertex form. And so if you want to say what the vertex is, so that's vertex form, standard form. So the vertex, if you want to go further, would be negative 9/2, comma, negative 89/4. Okay? All right. Let's look at number 5. Number 5, let's suppose in number 5 we have this. All right, so we have f of x is equal to 2x squared plus 12x minus 4. All right, now we're in a situation where the coefficient of x squared is not 1. Okay, so there are two approaches you can take here. All right, so to get this coefficient to be a 1, one thing you can do is now listen carefully. One thing you can do is divide both sides by 2. Remember, you have an equal sign, so it's a function. So you can consider this an equation because if you change this to y, you get y equal. So you have this equation. So let's go ahead and do that first. So I'm going to go ahead and divide both sides by 2. So here's what you do. Do this step first. You don't get yourself mixed up later on. So divide both sides by 2, just like this. So then this becomes f of x divided by 2. And then I get, now here's what I have. Now remember, you have all these terms divided by 2. So that means 2x squared divided by 2. Let me kind of remind you about this. So you see this right here? So just remember, you've had experience with this before in previous classes and even in this one. You can divide each term by 2. So you're going to get 2x squared divided by 2 plus 12x divided by 2 minus 4 divided by 2. And then simplify. The 2's divide out, so you get x squared. 12 divided by 2 is 6x, and then minus 2. So that is going to go here, okay? So that's this. So x squared plus 6x minus 2, all right? Okay, so now we're going to go ahead and add 2 to both sides to get the x's by itself. So I get this, f of x divided by 2 plus 2 equal x squared plus 6x. All right, so now that kind of looks like some examples we've had before. So example, let's look at let's remind ourselves about number 3. So you see we brought we added 3 to both sides, and when we did that, we had this left. So we had the x terms left, and that's what you see here. So you have the x terms left. Okay, now let's go ahead and complete the square on the x's. So you can take half. See, now this is now 1. The coefficient of x squared is now 1. So take half the coefficient of 6, which is 2, which is 3, and you square it, and you get 9, and that's what you add to both sides. You add that to both sides. Okay? So you have this, this, and this. Now let's combine like terms. So I can add 2 and 9 together, right? And so I get f of x divided by 2 plus 11 equal, this should now be a perfect square trinomial. So it'll be x plus 3 squared. Okay, now here's what we're going to do next. Okay, listen carefully to this. And you got to be careful. So let's go ahead and subtract 11 from both sides. Just keep the process the same that we've been doing in the past. Okay, so when I do that, I get, and I combine like terms, I get f of x divided by 2 equal x plus 3 squared minus 11. All right, now remember though, you got to get f of x by itself. So right now you're dividing by 2. The opposite is to multiply by 2. Now the next step is to multiply both sides by 2. But here's where you got to be careful. When you multiply both sides by 2, see here, think of this as one term, even though if you factor it out, you get several terms here. But think of this as one part of this expression and this as the second part of this expression. When you multiply by 2, when you multiply both sides by 2, everything here has to be multiplied by 2. So here's what I want you to think. So I'm going to rewrite this over. And when I do that, I'm going to multiply both sides by 2. Now, since that's 2 parts here, okay, 2 parts, a binomial squared and a constant, put that in parentheses or in brackets, and then say times 2 times 2, okay? Now the 2's divide out, and you get f of x equal, now distribute the 2. So 2 times that first part, and recall this first part, second part, 2 times this first part, so you can say 2 times x plus 3 squared, and then 2 times negative 11 is a negative 22. And that's your answer there. Okay, so that's your vertex form. I want you to notice though, you see this number a right here? This 2 right here? That's going to be the same 2 that was in the original problem. So remember, the original problem was this. Let me go ahead and rewrite it here. 2x squared plus 12x minus 4. So that, whatever, if this is your a right here, then this right here better be your a as well. Okay? And remember, that kind of makes sense because if I go back to the beginning of our lesson, you see in general form, the coefficient of x squared is a, right? Well, that a is the same as this a. So if this was a 5, then this better be a 5. If this was a negative 2/3, this better be a negative 2/3 when you're done. So this is 2, this is 2, okay? All right. Let's do another one. Okay. So let me show you the other way to do this problem. All right. So the other way. See how what we did was to get the coefficient of x squared to be 1. Because remember, you can only complete the square if the coefficient of x squared is 1. It's not. So we divided both sides by 2. That's the approach we took here. Let's do that same problem, but here's another way you could have done it. So the more knowledge you have about doing things in different ways, the better you're able to deal with future situations. So this is 5 star. Let's call it 5 star. So we have f of x equal 2x squared plus 12x minus 4. Now, when looking at both ways, you're going to have to decide which approach you take. Sometimes knowing both approaches may help you in different situations. But here's the second approach. So remember, when completing the square, we have to have the coefficient of x squared to be a 1. Right now, it's not. All right. So what I'm going to do first, though, is I'm going to add 4 to both sides. So let's go ahead and add 4 to both sides. And so I get f of x plus 4 equal 2x squared plus 12x. All right, now I want this to be x squared to be a coefficient of 1. So I'm going to factor out. So that second approach is to factor out that leading coefficient. So we're going to factor out the coefficient of x squared. So this becomes f of x plus 4 equal 2. And I'm going to factor a 2 out of each part. And basically all you're doing is dividing. So when you say 2 times what is 2x squared, just do this. 2 divided by 2 is 1. So you have 1x squared. So 2 times x squared is 2x squared. 12 divided by 2 is 6. So 2 times a positive 6x is 12x. Okay? Now don't put the parentheses just yet, because you remember you're now going to complete the square on well, let me go ahead and do that. So let's do that. So now, okay, so we factor out first. Now we can complete the square on the x's. So let me write this part over. Okay, now remember, let me go ahead and get a little smaller sticky note. Okay, so remember, you're going to complete the square on the x's, right? Okay, so x squared plus 6x. All right, now this is where you got to be careful. So I'm going to complete the square on the x. So on the x terms. So the coefficient of x is 6. When I take half of that, I get 3. And then I square it, and I get 9. So I'm going to put a 9 here. Now be careful. Be very careful. In a previous in a previous problem, let me get it. In a previous problem, when you completed a square and you added 25 on this side also, right? Okay, so that is what you did in previous problems. But I want you to remember, this 9, don't add 9 to both sides, because this 9 is also being multiplied by 2. So when you add 9 here, you don't add 9 here. You add 9 times 2. So I'm going to write this as 9 times 2, just so you'll know that this 2 came from this, because all of this is being multiplied by 2. So you're not really adding 9 to this side, are you? You're adding what? 18. So if you add 18 here, then you got to add 18 here. Okay? All right, so that's where you got to be careful when you factor out instead of dividing. So you see, when you divided by 2, you didn't have to worry about that, because when you divided by 2, that was a 1 right there. But here, when you factor out, you still have that 2 as a factor here. So you got to remember to multiply. All right, so that is one little area where some students forget about that. They'll add 9 to both sides and then right away mess up. All right, now you're not going to lose all your points, but if you were asked to graph this, which you will in the next lesson, and you were to change this to vertex form, right away you have the wrong graph, because you added the wrong number to both sides. Okay, so now let's combine like terms. 4 plus 18 is 22, so I got f of x plus 22 equal 2, and this is now a perfect square trinomial. 2 times x plus 3 squared. And I'll subtract 22 from both sides to get f of x by itself. You get f of x equal 2 times x plus 3 squared minus 22. And there's your answer. Okay? So notice, it's important you know how to do both now, because that does help you. So most students, well, it's up to you. So it's probably half and half. Half students will prefer to go ahead and divide both sides by the coefficient of x squared. Other students will just go ahead and factor out a 2, but be very careful. You don't add 9 to both sides because you're multiplying by 2. So you're really adding 18 to both sides here. Okay? All right, so let's look at number 6. In number 6, let's suppose we had this in number 6. All right, so let's say we had f of x. We're going to do another one like this. F of x equal 4x squared minus 32x plus 61. Okay. All right. Now again, notice the coefficient of x squared is not 1. So let's go ahead and subtract. Well, let's go ahead and divide both sides by 4. And so I'm going to go ahead and subtract 61. Let's do that first. Subtract 61. So I get f of x minus 61 equal 4x squared minus 32x, right? Okay. Then we're going to divide both sides by 4. So I'm going to divide both sides by 4, just like this. See this right here? Okay. Now what I'm going to do here is I'm going to rewrite this. So remember, let me go ahead and get into the sheet of paper. So remember, this right here means this. And leave this, well, let's go ahead and divide, let's go ahead and rewrite all of this. So let's start with this here. So 4x squared minus 32x divided by 4, I can write as 4x squared divided by 4 minus 32x divided by 4. And so this becomes x squared, 32 divided by 4 is 8, minus 8x. And so that is going to be this. And I said I was going to rewrite this as 2 separate parts, but I'm going to leave it as that for right now. So this becomes f of x minus 61 divided by 4 equal x squared minus 8x. Okay? All right. Now, so now we have the x squared having a coefficient of 1. So now we're going to take the coefficient of x, which is negative 8, divide by 2. I get negative 4, and I square it. So when I square it, I get 16. So that's what you add to both sides. So plus 16 plus 16. Okay? Now, I'm going to go ahead I'm going to go ahead and write this as f of x divided by 4 minus 61 divided by 4. So f of x divided by 4 minus 61 divided by 4, and then plus 16. And the reason is because I want to go ahead and write this as one fraction. So equal, and when you do this part, this should now be a perfect square trinomial. So that's going to be x minus 4 squared. So let's use just a calculator in this part right here. So let's go ahead and add these together. So negative 61 divided by 4 plus 16. So again, negative 61 divided by 4 plus 16 equals, oops, let me do that again. Negative 61, yeah, that's right. Okay, so we get this. All right, now most of you know that 7/7500 is 3/4. So this is going to be 3/4 right here. So if you don't remember that that's 3/4, then just say second PRB, and then press equal, and you get 3/4. Okay. If you do it by hand, let me just remind you, if you do this by hand, what this is. So you get negative 61 divided by 4 plus 16 divided by 1. So the LCD is 4. So you're going to write equivalent fractions. Well, the denominators here are the same, so the numerators have to be the same. So 61/4 is equivalent to itself, right? Over here, I got to multiply by 4. And when I multiply by 4, 16 times 4 is going to be 64. And so negative 61/4 plus positive 64/4 is a positive 3/4. Okay? All right. So now this right here becomes f of x divided by 4 plus 3/4 equals x minus 4 squared. Now we're going to subtract 3/4 from both sides. So subtract 3/4 from both sides. And so I get f of x divided by 4 equal x minus 4 squared minus 3/4. Okay? All right, now just like in our previous example we did here, so once you get to that point right here, now we're going to multiply both sides by 2. So you can do the same thing now, except this time you're going to multiply both sides by 4. So let's go ahead and rewrite this over. And what I'm going to do now is I'm going to put that in brackets because you have two parts, this part and this part. It's going to have to be multiplied by 4. Okay, you can multiply both sides by 4. So these 4's divide out, so you get f of x equal. Now you can distribute, so this part times 4 and this part times 4. So you get 4 times x minus 4 to the second power, and then 4 times the negative 3/4, 4 times 3/4 is just 3, right? So that's minus 3. And so there's your answer. So that's your vertex form, your standard form. All right, now that was when we just went ahead and divided by 4. So let's go ahead and factor out a 4 this time. So let's see what happens if you just factor out the 4. So let's do it that way now. So this is 6 star. So we have f of x equal 4x squared minus 32x plus 61. So let's go ahead and subtract 61 from both sides. And so I get f of x minus 61 equal 4x squared minus 32x. So I'm going to factor out a 4 now. So let's go ahead and factor out a 4. So that's the second approach, is to factor out a 4. So I get f of x minus 61 equal 4 times x squared minus 8x, right? Okay, so now we're going to complete the square on the x's now. So let me go ahead and rewrite this over. So f of x minus 61 equal 4 times x squared minus 8x. So I'm going to put the parentheses when I add something here. So I'm going to have to add something to this to get this to be a binomial squared. So I take half the, cover this up if you need to. I take half the coefficient of negative 8, divide by 2, I get negative 4. When I square it, I get 16. So I'm going to add 16 here, but remember, be careful, don't add 16 here either. That's not correct, because at 16, you're not really adding 16 to this side, you're adding 16 times 4. So don't forget to do that part. So this is now plus 16 times 4, okay? And 16 times 4 is 64. And so now, when you combine like terms, negative 61 plus 64 is just 3. And that should sound familiar, right? Because that was at 3 here. See that? That was at 3 here. So you get f of x plus 3 equal 4 times, and this is now binomial squared. So you get x minus 4 squared, and then just subtract 3 and you're done. So f of x equal 4 times x minus 4 squared minus 3. All right. So just think about which would be easier for you. All right. So in this problem, it seems like you would say, well, that looks a little bit better to deal with than this, right? Okay. All right. So let's look at another one. So let's do number 7. All right, in number 7, let's suppose we had this in number 7. All right, so let's suppose we had g of x is equal to 3x squared plus 4x minus 9. All right, and let's go ahead and do this both ways as well. So we're going to go ahead and divide. Well, let's add 9 to both sides. I'm going to add 9 to both sides. And so I get g of x plus 9 equal 3x squared plus 4x, right? Because this is 0. So now, remember, you want, before, when you're dealing with completing the square, the coefficient of x squared has to be a 1. So let's go ahead and divide both sides by 3 now. Divide both sides by 3. All right, and then let's write this as separate fractions. So I get g of x divided by 3 plus 9 divided by 3 is 3 equal 3x squared divided by 3 is just x squared. And then over here, though, be careful. So this is now 4/3 x, right? Plus 4/3 x. All right, now, okay, so now we're going to complete the square on the x terms. So the coefficient of x this time is 4/3. It's not an integer. But you still have to divide by 2, right? Well, dividing by 2 means the same thing as multiplying by a half. So this is 4/3 times a half. Well, 4/3 times a half, 4 times 1 is 4, 3 times 2 is 6, and when I reduce, I get 2/3. So 4/3 divided by 2 is 2/3. So then you take 2/3 and you square it, and you get 4. 2 times 2 is 4, 3 times 3 is 9, so you get 4/9, and that's what you add here. So you add 4/9 to both sides. Okay? So that's what you add to both sides, 4/9. And so combining like terms here, 3 plus 4/9, so 3 plus 4/9, 3 plus 4 divided by 9 equals, and then rewriting that as a mixed number, you get 3 and 4/9, and then changing 3 and 4/9 to an improper fraction. 9 times 3 is 27. 27 plus 4 is 31. So you get 31/9. So this becomes g of x divided by 3 plus 31/9 equals, and this should now be a perfect square trinomial. So when you factor this, and remember, think of that last term right here, because that last term, you can write it as a binomial, as a rational number squared, because both 4 and 9 are perfect squares. That's always going to be the case. These are going to be perfect squares. So you're going to get x plus, remember this plus here, so you learned all about this last semester when you dealt with factoring. So x plus 2/3 squared, and so that's what this is. 2/3 times 2/3 is 4/9. 2/3 plus 2/3 is 4/3. And then now we're going to bring this, so remember, now we got to get g of x by itself. So now we're going to subtract 31/9 from both sides. And so I get g of x divided by 3 equal, this is 0 now, so you get x plus 2/3 squared minus 31/9. And now the next thing you're going to do is get g of x by itself. So right now you're dividing by 3, the opposite is multiplied by 3. But remember, think of this as parts. First part, second part has to be multiplied by 3. So times 3 times 3. So these 3's divide out, so you get g of x equal, so remember, you're distributing both, you're multiplying both parts by this 3. So you get 3 times this first part minus, and then go off to the side and figure that part out. So 3 times the second part. So 3 times 31/9, right? So reduced, 3 and 3 is 1, 3 into 9 is 3, so you get 31/3. So it'll be minus 31/3. And so there's your answer. And always verify that the a is at least. So this a is 3. In your original function, the a was 3. Okay? All right, so that's just going ahead and dividing both sides by 3. Let's go ahead and do the same one by factoring, by factoring out the 3. So let's see what happens there. All right, so this is going to be 7 star. So 7 star. All right, so when we do that, the same function, g of x equal 3x squared plus 4x minus 9. So we're going to go ahead and add 9 to both sides. So add 9 to both sides. So g of x plus 9 equal 3x squared plus 4x. All right, so what we're going to do now with this approach is we're going to factor out the 3. So we get g of x plus 9 equal 3 times, all right, now remember what we talked about in a previous problem. So remember, when factoring out the 3, just like you did in a previous course, you're going to say 3 times what is 3x squared, and 3 times what is 4x. And to get that, you're just taking the coefficient dividing by this number, 3. So 3 divided by 3 is 1, so this should be 1x squared, right? 3 times 1x squared is 3x squared. 4 divided by 3 is 4/3. And so this should be 4/3 x. It kind of makes sense because 3 times 4/3 is 4, right? And that's what you wanted. All right, so that's this. All right, so I get g of x plus 9 equal 3 times x squared plus 4/3 x, and then leave some room here because now you're going to complete the square on the x term. All right, so remember the coefficient of x squared is now 1. Cover this up, so now we can complete the square on these x terms. When I say the coefficient of x squared is 1, I mean the coefficient of x squared that's inside this parentheses. Technically, the coefficient of x squared when you distribute it is actually 3, but you're completing the square on this part for right now. So you're going to take half of 4/3, so 4/3 divided by 2. So when you take half of 4/3, remember that's 4/3. Change this to multiplication, so you take the reciprocal of 2, which is 1/2. So I get 4/3, which is, I'm sorry, 4/6, which is 2/3, right? 2/3. So then you're going to take 2/3 and you're going to square that. So 2/3 squared gives us 2/3 times 2/3 is 4/9. And so you're going to add 4/9 here. But be careful, don't add 4/9 here, because remember that you're not really adding 4/9 to this right side of the equation. You're adding 4/9 times this 3. So you got to figure out, well, what is 4/9 times 3? Well, reduce, that is just 4/3, right? So you're gonna, so on, even though you added 4/9 here, you really added 4/3. You added 4/3. So you're gonna add 4/3 here, which you already have, and then you're gonna add 4/3 here. All right, so you got to be careful. Whenever you do the factoring out, be careful. You're not adding 4/9 to both sides. Don't forget that's really 4/9 times this factor you factored out. Okay, so now 9 plus 4/3. So 9 plus 4/3 should give you 10 and a third, right? All right, if you can't see that, use your calculator. 9 plus 4 divided by 3 gives us 10 and a third. See, that's a third, 0.323. So you get 10 and a third. So 3 times 10 is 30. 30 plus 1 is 31. So you get 31 thirds. So you get g of x plus 31 thirds equals 3. And this should now be a perfect square trinomial. So when you factor, you get x plus 2/3 squared. And then subtract 31 thirds from both sides. You get, and combine like terms, you get g of x equal 3 times x plus 2/3 squared minus 31 thirds. And that's the same answer you got here when you did this approach. All right, when you did this using this approach, you got the same answer. All right, just different ways of doing the same problem. And then let me do one more, and I want to do this one because in all the problems we've done, the coefficient of x squared was always positive. Let's do one where it's negative. And we're already pretty long in on this lesson, so let me just do this one. Number 8, let's suppose in number 8 we had f of x equal negative x squared minus 10x. All right, so just like before, let's go ahead and, since there's no constant term here, let's just go ahead and factor out a -1 from here. So we're going to do the factoring. Or if you want, let's be consistent. We're going to do it both ways. One where we divide, one where we factor. So be careful though. The coefficient of x squared is a -1, so you can divide both sides by -1. Okay, that's one approach. Divide by -1 to get this to be a positive x squared. So I get f of x divided by -1, and leave it as -1, by the way. Don't write it as negative f of x. Just leave it as -1 for right now. Just be consistent with what we've done in the past with these problems. Equal. All right, now just to remind you, let's look at this. So you see this right here. I'm going to rewrite it. Negative x squared minus 10x divided by -1. So we're going to take each term that's in the numerator, divide by -1. So negative x squared divided by -1 minus 10x divided by -1. Remember, this one should be -1. So -1 divided by -1 is a +1. So that becomes x squared. A -10 divided by -1 is a +10. So you get plus 10x. So that's what this is. So this right here is this. Okay, so you always have to be careful with all these little things that can mess you up. So x squared plus 10x. And now all we're going to do, and so now we're going to complete the square on the x terms, because this is now a coefficient of 1. So half of 10 is 5, right? So 10 divided by 2 is 5. Then you're going to square that, and you get 25. So you're going to add 25 to both sides. And let me go ahead and rewrite this over. So f of x divided by -1 equals x squared plus 10x. So now we're going to add 25 to both sides. So plus 25 plus 25. So what I get here is f of x divided by -1 plus 25 equal, and this is now a perfect square trinomial. So it'll be x plus 5 squared when you factor. Subtracting 25 from both sides, I get, this is 0 now. When you combine like terms, I get f of x divided by -1 equal x plus 5 squared minus 25. And now all you're going to do is multiply both sides by -1. But remember, when doing that, think of this as parts. First part, second part. So let me go and rewrite this over. And I'm going to put that in brackets. X plus 5 squared minus 25. All right, so think of this as parts. So times -1 times -1, right? So the negative ones divide out, you get f of x. So f of x equal, and then go ahead and get rid of the brackets. You're going to say -1 times the first part and -1 times the second part. Okay, so -1, or just, I'm just going to say negative in parentheses x plus 5 squared. All right, and then -1 times a -25 is a positive 25, and so there's your answer. Okay, so that's what you do if you're going to divide. Now let's go ahead and factor out. So let's do that same problem, but this time we're going to factor out a -1. Okay, so if you get stuck, basically, you see, knowing both ways helps. If you get stuck with one little part, you're like, I don't know what to do, then try that other approach. But then eventually come back and figure out, well, figure out why you couldn't go any further, because you really need to know the process as far as many things as possible. So you have -x squared minus 10x was the original function. Okay, so notice there's no constant there, so there's nothing to worry about at that point. Now I'm just going to go ahead and factor out a -1. So when I factor out a -1, I'm going to -1 times x squared plus 10x, right? Because -1 times x squared is -x squared. -1 times a positive 10x is a -10x. Now I'm going to, let me write this over. I'm going to write this over. So f of x equal -1 times x squared plus 10x. And this is the part where we're going to complete the square. So I'm going to leave some space here. So I'm going to complete the square on the polynomial that's in parentheses. So if you're looking at the polynomial that's in parentheses, so that's why you should cover up this factor that you factored out. We see this now 1 here. So half of 10 is 5, right? And when I square 5, I get 25. So I'm going to add 25 here. Now remember, you're not really adding 25 to both sides, because you're not really adding 25 to the right side. You're adding -1 times 25. So what you're going to add to both sides, you're really adding a -1 times 25. So you're adding a -1 times 25 to both sides, right? Okay. So now this is a -25. Keep that in mind. So I have f of x minus 25 equal -1, and this should now be a perfect square trinomial, and it is. It will be x plus 5 squared. Now let's get f of x by itself. So now I'm going to add 25 to both sides, and when I do that, this is 0. So I get f of x equal, and I'm going to just write this as negative x plus 5 squared plus 25. And there's your answer. So it's that same, so this was 8 star. So it's you get the same answer no matter what approach you take. But notice just if you just put the two on the side of each other and just go through the process. In some cases, you may want to use this approach. In some cases, you may want to use that approach. All right. So that is, we're at about 53 minutes now. So that's going to be the end of that lesson. Now, remember, in this lesson, just to remind you what the point of it was. So in this lesson, the goal, the objective, was to, given a quadratic function in general form, you needed to know how to complete the square to get it to standard form or vertex form. And that idea is important, because once you go from here to here, then you could use this to help you graph this quadratic function, because you know from previous lessons that about transformations, about parent functions, shift. This is a horizontal shift. This is a vertical shift. This A here, if it's negative, there's going to be a reflection. Depending on whether it's greater than 1 or less than 1, it could be a stretch or a shrink, and so on. Okay? All right. So that is the end of this lesson.